record now and we'll get going. Yeah, so just a reminder, we're recording, so if you're not comfortable with that, please feel free to turn your webcam off and we'll get started. Sorry, it's going really well. Right, sharing the screen. Don't worry, we'll trim this bit off the video.
Seamless start, yeah.
Right, can everyone see, can you see the slides okay?
Yeah.
Perfect. So this is just going to be a short presentation to go through the basics of SQL. We've tried to make it so if you're new, it should hopefully be a nice, easy introduction. And I'm just going to apologise in advance. So normally we would include memes in our talk. We've got a few, but the SQL jokes aren't the best. And just if you're not familiar with SQL, it's just to let you know that SQL contains tables, so there will be some terrible jokes about bars and restaurants, so apologies in advance for that. So in terms of what we'll be covering in this talk, first of all, we're just going to have a quick overview of web application architecture, so what it looks like behind the scenes in case that's something you're not already familiar with. We'll also have a chat about the relevance and implications of attacks on databases, which is what SQL injection is linked to. And also, if you're new, we're going to be talking about what is SQL and what is an injection attack, so you'll know what we're going to be doing in the labs. We'll talk a little bit about how we're going to attack GShop. So when you see Jenny and Sarah and Sophia doing their demonstrations, it will be a little bit familiar to you already. And then at the end of this presentation, we'll just briefly cover steps how to mitigate against this attack and also some useful resources. So if you're interested in learning more, some places to go for that. So to start off with, this is, if you're not already familiar with it, this is what a web application looks like. And you'll also sometimes hear the terms front end and back end to describe that. So the front end is the part of the web application that you see, and you'll usually view that in a browser. So when you open your browser, go to the website, the front end is what you'll see and interact with. And as part of that, you'll have information displayed, and there'll also be input boxes that you can put information in to interact with, like login boxes, places to put your credit card details, those sorts of things. When you put some information into that front end, it's passed to a server, which then communicates with a database, queries the database, collects the information from the database that it's asked for, and then presents it back to you in the front end in the browser. So you can see little person in the top left-hand corner makes their request, goes to the server, the database, and then that information comes back and is displayed in the browser and makes them happy. Another term that you might hear about is the web stack, and what that is it's just a term to describe the tools and technologies that are used in web development. And I've just put some little annotations of some tools and technologies you might hear associated with the front and back end. And just to mention that today we're going to be primarily looking at the database, which is on the right hand side, and there are two types of database, SQL databases and no SQL databases, and we'll come on to what that means in a little bit. So it's really important, if you've got a web application for your users, that we're able to have easy access to the database. And the reason for that is basically this is the architecture of a huge amount of web applications. So any site that you need to log into that has a personalized experience for you, shopping, so many things rely on this architecture. And if we can, as a user, can access that database easily, it makes our life really easy, and it's going to be a good experience for us as users. But there are times when easy access to the database can be bad, and we need to make sure that whilst it's easy for our users, it's not super easy for anyone. And this user, you can tell, is a bad person because they're wearing a black hat. That is a foolproof way to tell if someone is naughty or not. If they're wearing one, they're naughty. If they're not, you're perfectly safe. But this person, as an attacker, can potentially, if we don't have appropriate safeguards in place, can access that database. And one thing they can do that's bad is they can take data from it. They can steal your data. They can do things to the data that can cause problems, and we'll cover that shortly. But also, if you've not put appropriate safeguards in place, this type of attack can also be used in remote code execution on the host machine that holds the database. So whilst we want to make our users' life easy, we also don't want to make it easy for the baddies. So in terms of consequences of this type of attack on the database, so in terms of how it affects confidentiality, so obviously, if someone's got unauthorized access to your data, that's a data breach waiting to happen. And we're quite familiar with all the consequences that can happen with that. There's a lot of crime that can happen with stolen data. And also there might be stuff on there that you don't want people to see. In terms of impact on integrity of data, so with this type of attack, it is possible to actually alter data within a database. And the consequences of that can range from being inconvenient. So say you bought something online and someone broke in and changed your address and your shoes went to the wrong place. That's inconvenient, but it's manageable. Whereas when you think about databases that hold sensitive information, for example, things like medical records, if that's something that can be tampered with, that's potentially really, really bad. And in terms of accessibility, you can, with this type of attack, you can maliciously delete data, and obviously that's really, really bad. And sometimes when that data is deleted, it can be almost impossible to recover. So those are some pretty severe consequences. And also, as we've mentioned, there is the potential to use that database as a foothold to interact with the operating system and cause things like remote code execution on a machine and gain access to a system. So that's all potentially really serious consequences of this attack. And just to say why we're talking about this attack, so there's 10 things in the OWASP top 10. We've picked this one because whilst other attacks sort of rise and fall in terms of their popularity, injection attacks have consistently been at the top of the OWASP top 10 since 2010. So whilst it's important to note that that's not just SQL injections, that's a range of injection attacks. They are something that is a persistent problem, and it's something that is very important to be aware of. So what is SQL? So to start off with, I've been dragged up to say SQL, but you might also hear people calling it SQL. It doesn't matter. It's the same thing. It's just personal preference, so it doesn't matter how you say it. SQL stands for Structured Query Language, and it is a language that is used to communicate with databases, and that's something it's very specialized for. And then this is just some information about databases. So SQL databases are called relational databases, and they are made up of tables, fields, rows, and columns. And what you'll tend to find is a database will be made up of lots of different tables, and each table should be about a different thing. So for example, with a web application that's for shopping, sorry, I'm talking about shopping a lot, you might have a table that holds customers' credentials so they can log into their account. You might have another table that has their shopping history. You might have another table that has things like their credit card details. And each row in a table is called a record. Each column heading is called a field, so that tells you what data is in that column. And each row has a primary key. So for example, each user might have a row that is their row that's got all of their data in. It's got a primary key, so you can link them together. And also tables will have, as well as that primary key to identify that data, they will have foreign keys, which means you can link tables together and retrieve lots of different types of data in your queries. This slide is just to give you a little bit of information about the difference between SQL and no SQL. So as I just mentioned, SQL is table-based, so it's lots of tables that can be linked together, but it's very structured and ordered, whereas no SQL is more flexible. And you can see from the diagrams on the right-hand side that it's more of a collection of documents that are loosely linked together. On the left-hand side, you can see some software, examples of software that's used in SQL databases. And on the right-hand side, you'll see some examples of software used in no SQL databases. If it's got OS next to it, it means it's open source, and you should be able to freely access it if you want to have a look at it. So the next question is, what is an injection attack? And an injection attack is where an attacker puts something malicious into an input field in a website. And that becomes a problem when that malicious input hasn't been anticipated by the developer, and it's just processed as normally by the software. The software just thinks it's a command or a query, and the software just goes off and does exactly what the attacker wants. Again, it's not just SQL that we can use in injection attacks. There's lots of different things we can inject into websites, but that's what we're going to be talking about today. And also, this is a very special custom meme made by Sarah and Sophia, which is brilliant. And if that doesn't already make sense to you, it will make sense by the end of the evening. Basically, there's a happy little search bar who doesn't know what's about to hit them. But yeah, if that command's not familiar to you, we'll explain that soon. So in terms of the types of attack we're going to see this evening, the ones we're going to demonstrate are what are called inbound or classic SQL injection attacks. And what that means is the data is collected through the same comms channel that is used in the attack. So in this case, what we're going to do is we're going to attack using HTTP requests in a browser, and the information that is coming back from the database is going to come back to us through the same route, and we're going to see it in the browser. So it's a very straightforward way of doing it. In terms of a couple of types of attacks, you'll see if we've got time for all of them. So we're going to show you an error-based attack. So what that is inputting a string that isn't designed to retrieve data from the database. It's designed to cause an error. And what we can do is use that to gather information on the database. And we're also going to show you some malicious inputs that can be used to retrieve database data. And one example of those attacks is a union-based attack. So what you'll do is piggyback on an additional query onto one that's legitimate and get back more data than you should from that. And then just aside to say that other attacks are available. We're not going to cover them all this evening just because we're a little bit short on time and we'd like to keep it simple. We are going to be using some Boolean statements, so true or false statement, as part of the attacks we're going to show you today, but they can also be used in another type of attack called an inferential or a blind attack. And that's another type of attack where you put a string into the database. You're not trying to get information from the database out, you're just trying to gather information on the system. So that's another type of attack that you can use some of the things that we'll show you tonight for. And also just to say there are other types, but they're out of scope just to keep this evening nice and short and simple. So this slide is just to show you some examples of some SQL query components that you're going to see coming up in the lab. So just to give you a little bit of familiarity before we start, if it's new to you. The first one at the top is a single quote, and these are used to bound SQL query fields, and they are something that is automatically added before the query is passed into the database. And these are really useful because firstly, you can use these to trigger an error quite straightforwardly, but you can also use these to manipulate queries and change where the database reads, and we'll show you how to do that shortly. The next one is the double dash, and that's a comment. So what that does is when you include that in a string, the database will just ignore the rest of that query. So again, you can use that to manipulate queries that are being passed in, including quotes that are added when it's passed to the database. So it reads quotes that you've put in. So it's really interesting. It's going to be really interesting to see that. Another thing you'll see us using later is logic statements. So 1 equals 1 and 1 equals 2. Basically, these are just statements that are evaluated to either true or false, and that logic is then used in the database query. So 1 equals 1, we know that's true, and 1 equals 2, that's false. So it's that straightforward. And then towards the bottom of this slide, you'll also see some of the words you'll see in SQL queries themselves. So select star from basically just means select all data from, and then at that point you can say, for example, name a particular table, and it will return everything from that table to you. Union is a command that will combine the results of 2 select statements. So you'll make 2 queries to the database to select data, and then you'll combine them into the output that's passed back to the user. Where just adds a condition. So for example, where ID equals 1, it will return everything from the database where that condition is met. So the row where ID equals 1 is very straightforward. And then and or are words that is used as well. And they'll usually define multiple things that need to be checked before it passes back from the database. And then this slide is just to start to show you what we're going to be doing and how it's going to affect what's going into the database. I'm really sorry, I realised just before we came on that it's in red and green. So if there's anyone who's colourblind, my apologies, but you should still be able to see what we're aiming. So the first string at the top is basically the query that the database is expecting. And within this query, you'll be able to see there's a $username in quotes, and also a $password in quotes. And what those parts in quotes are, they are going to be the strings that are put into the fields in the user interface. So you imagine when you're logging into a website, there's a box for you to type your username in, and there's a box for you to type your password. So when you do that, if that website's using an SQL query, it will put those values into these boxes here where the green box is, and then pass them to the database, and it will use your username and your password to match the right part of the database and return that to the front end for you. What we're going to be doing is the second part. So you can see in red, we're going to put a short string, so admin quote or 1 equals 1 dash dash. And what you can see is if we put that into the username box, the application will put it into the query there. But what it will also do is, using those quotes, it will then disregard the rest of the query. So the area in pale grey is something that's not going to be interpreted by the database. So if you look in the third line, you can see with that short malicious string that we've passed in, we've completely changed the query that's going to the database from the one at the top, which requires matching a username and a password, whereas this one, we don't need a password to return any information. So it's really interesting how just with that one little short string, we can completely change the query that's going into the database. Another thing to mention is destructive SQL queries. So as well as trying to get information about the database and data from it, you can also do some bad stuff in there, and you can actually start deleting information. What I would say is just be really careful if you're going to play with these. If you're playing with something like G-Shot, and it doesn't matter if you break it because you can just spin up a new one, but just be really, really careful with these. Delete, there's a way back, basically. Stuff is logged and you can roll back the changes. But if you start using things like drop, you can potentially delete whole parts of the database or the whole database. And unless you've got a backup, that data's gone forever. So just be really, really careful with those. And then just for anyone who's interested in the blue team side of things, we'll just talk a little bit how to mitigate these attacks. So it's really important if you're designing web application just to bear in mind that not all users are going to use it how you want them to. And most people are going to be good and just type in their username and password, but there are bad actors out there who are going to exploit it. So build that into your products. Sanitize your inputs from user interface and use prepared statements. So basically have safeguards in place that the code that's going into those input boxes isn't just passed straight to the database without checking. Make sure we're checking it for bad stuff. Also, there's things that you can do, like if you've got sensitive data in there, like passwords or financial information or anything like that, encrypt it when it's stored. So even if attackers are retrieving that information, it's encrypted and it's not useful for them. The other thing you can do, we're going to show you how you can use error messages to gain information about the database. So you can actually configure your database so when an error is generated, that information doesn't go to the user. The user is just told there's been a problem and you don't really need to tell them any more than that. And then it's just all the usual stuff, really. So make sure you're connecting with the minimum possible privileges. Don't run everything as admin because that's never a good idea. Make sure you're only using the functionality you need because any stuff that you're not using is a potential foothold. And then just all the usual stuff, like make sure your software's up to date, patched, and make sure you've got a backup in case anything does go wrong. And then finally, so in terms of useful resources, so there's a woman called Rana Khalil who she's active on Twitter and she's got a YouTube channel. She's done a really great video on SQL injection and the link is here. And as I said, the slides are going to go into Slack, so don't worry about writing this down, or you can Google for it. And also, if there's anyone who's looking at OSCP, she's documented a lot of OSCP stuff on her YouTube channel and her Twitter, so she's definitely worth having a look at. And she's a lady, so I think she's really cool. Also, there's loads of OWASP resources. There's some links here. And also, if you Google OWASP GShop and SQL injection, there's lots of resources out there for you. And also, Portswig is another really good one if you are looking for information on this or other red teaming stuff as well. So what I'm going to do is I'm going to pause the recording and then I'm going to pass you over to Sophia, who is going to talk you through how you would approach this as a tester in real life.
Ooh.
Sorry, Sophia.
That's okay. So I'm just going to quickly talk about how you would approach sort of SQL injection or SQL injection in real life as sort of a pen tester or a web app tester, that kind of thing. So the first thing you want to do, which is absolutely key to anything in sort of pen testing or before you even start tinkering and exploiting and doing all the fun stuff, is you have to do your recon. So look through the web app, go through it, click buttons, try search fields, try to get a grasp of the functionality of the web app itself. Sarah's going to do a little bit of a demo of this afterwards with GShop, just to give you a rough idea. So another thing that sort of testers use in real life are interceptors to capture data. So what an interceptor does, it sits between the client and the server. So when you visit a website, it will try to communicate with the server, and an intercept will sit in the middle of that connection It will grab the request for you and it will hold it so you can have a look at it in more detail. So there are loads of different kind of software that you can use. There's Burp, which is very popular, and there's also Zap, which is actually run by the OWASP Foundation. And using an interceptor, you can start to do more fancy stuff like fuzzing attacks. So what we mean by this is sort of automating, testing loads of different payload and testing loads of different requests. And you can even do automated testing as well. But this is always recommended to do in addition to manual testing, because it tends to be with automated testing that it just fires a lot of random stuff at the website. And that's not really recommended, just in case it breaks things and you don't know why it's broken and it all goes terribly wrong. So again, you can use things like interceptors like Burp Active Scan. You can use tools like SQL Map, which I'm going to talk about a bit in a second. But yeah, massive word of warning. Try not to be too aggressive on websites that are out of your control, because if it crashes, that could be a very big problem. And particularly if you're a pen tester, the client won't be happy with you if you crash their entire website. So definitely a word of warning if you start to fire loads of stuff at the website. Manual testing is definitely the way forward, of just sort of sending one-off payloads one at a time. And I tend to kind of go that way anyways, because I understand it more if I'm actually physically manually doing it rather than running random scripts and stuff. So I've just got a little bit of a demo here where I used SQL Map against the DVWA, which is the Damn Vulnerable Web App, I think. Yeah, which is basically a web app that you could just break, essentially. It's made to be broken. So I thought I'd use this against that, and hopefully you should be able to see some cool stuff. Oh no. Right. So this might be a little bit small, so I'll read it to you as well. So what we're running is SQL map -u, and we're just running it against the website itself. And what we have to do is we have to use a cookie in this particular instance to authenticate ourselves for it, the scan to be able to run. So we're just putting that in as well. And by doing -dbs, we're trying to figure out what database it is. So you can see it's doing a lot of automating, where it's just sending a bunch of stuff. It's trying to figure itself out. And eventually it will get the right payload to get the right information back. So I think this takes a little bit. So it's identified the vulnerability on the website itself. So it says the parameter ID is vulnerable. So it's already done that for you. And it gives you a bunch of information, what it actually did. So it used error-based, time-based. So this was all the kind of different attacks that Nat was talking about. So it managed to succeed in a few of those. And it's identified that the database is MySQL. And it's identified all the database names as well. So you can then use this tool to dig a little bit deeper. Now that we know more information about the web app itself, we can ask it to dump databases. So we're using -d for database and using DVWA, and then trying to get the tables from that database. So we've got guestbook and users here. And then we can go a step further and we can start querying for things like columns. So we've specified the DVWA database, the users table, and now we're asking for the columns. So you can see here that SQL Maps managed to get sort of password, user, avatar. So that's kind of the juicy stuff that we want to try get. And now we can use sort of my favorite option of all in SQL Map, which is dump all, which it's kind of does what it says in the tin. It will literally get everything it can from that particular database. So when we use the dump all option, it should spit back some hashes for us. And there we go. So using kind of a step-by-step process, you can use an automated tool like SQL Map to do some of the kind of fuzzing for you that you would have had to done manually. And then through that, you can use different options to make it a little bit nicer and a nice little GUI. And the good thing about SQL Map is it logs everything for you. So you don't have to worry about screenshotting or copying stuff. SQL Map does that for you. And hey, we've got passwords that you can try crack and do what as you please. So that was just kind of my little snippet on what you could do in a real life scenario. And I guess I'm passing back to Nat now. So,
Thanks very much. So what we'll do now is we'll just pause the record.
Go on then. Okay, so hopefully everyone's back after the break. If not, we're starting anyway. So this is GShop that we're going to be looking at today. So GShop is a web application that is done by OWASP, and it's got lots of security vulnerabilities in there, and it's sort of like anti-best practice. If you looked at the source code, it just looks like an absolute mess, and as a software engineer, it doesn't look nice. But it's really useful for training and for demonstrating security risks in a lovely, friendly format where you are breaking stuff, but you're supposed to break stuff. So we're going to be going through 2 SQL injection challenges tonight, but before we get going, this is what GShop looks like if you've done it up for the very, very first time. So the first challenge is actually finding the scoreboard. So you can see the scoreboard is not on the main page. So if you were, clicking around, you're not going to just find the scoreboard. So this is like the first mini challenge. So we thought we'd walk you through that today just to get started. So this is GShop. You could have a go guessing what the path would be in guessing the URL, but if we just give it a go, hopefully, you saw what it was already. I forgot that, of course, I've searched this a lot of times checking how to go through it. But if you went to scoreboard or one word, you're not going to find it. And you could guess it, as you've probably now just ruined it. Or we could go for the more technical approach to getting there. So what we're going to do is we're going to click inspect, and this has opened up the dev tools. You can also do F12 or I believe Control-Shift-I also gets you up here. But this is the dev tools, and this is a really useful place to learn lots of different stuff that is behind your web application. So if you haven't seen the dev tools before, I'm just going to give a super quick overview to sort of these first 4 tabs along the top here, because they're sort of like the really important ones that we like. So this is the Elements tab, and this is where you have the page HTML and the CSS going on here. You can edit stuff in here, and that edits it locally, and you can see what does it on the front end. So if I'm doing any front end development and I want to know what I want to do with my CSS, I will often play with it in here to check that it doesn't look ugly before I put it in the actual code. The CSS is horrible. This is the console tab, and this will have any logged messages in there, and you can also run JavaScript. So I could write some JavaScript in here and it would do it and run it there. Then we have sources, and this has, there we go, a load of files that are behind the web application. So we have some images in here that we wanted to look at images. We've got some JavaScript files. So that's some code that is behind, and we're going to have a look at those in just 1 second. And the styles.css, that's some CSS that goes behind it. And then finally, we have the network tab. And when you open up DevTools, this starts recording all the network requests going on behind the scenes. So we're just going to go to the sources tab, and this we're going to look at main.es 2018.js. It's a very catchy name. And you can see that this is the file here, and right now it is minified. So it is one long line, and it is not very nice to look at, but in computer terms, it's removed all the unnecessary and redundant data in there. So all the comments are gone, any unused code, it's shortened all the variable names, and it makes the code much smaller for page optimization. But if I click on the pretty print and I wait a second, it gets formatted, and it's just a little bit better to look at. So it's still not completely the same as the source code, but it's much easier to just read and understand. It's got a bit of formatting in there, and so it's not just horrific. So the idea to find the scoreboard is it's somewhere in here, but this is 14,000 lines. I'm not going to go through all of that. So it's helpful to know some things that you might want to search for in order to find that. So what I'm going to do is I'm going to find another page to see if I can find what another page would look like. And then I can find all the paths for all of the pages on here. So I'm going to go to photo wall, which is another thing here, because it's got a slightly distinctive name. So it's got photo dash wall, got some photos. If you want to continue with other challenges, you can fill in this one and then some other things that you might be able to use on this page. But I can see here that the path at the top, hopefully you can read that, is photo-wall. So I'm just going to give that a search. So just do a Control F at the bottom there. So there's good. There's only 3 instances of photo wall in this whole 14,000 line long bit of code. So that's much easier to look for. So I'm just going to put down. And then this looks really, really good. This is the kind of thing that we wanted. So you've got paths here, and there's your photo wall, contact, basket. These are all the kind of things that we're looking for. So if we just have a little scroll down, see what it has, and there we go. We have the scoreboard there. So we can see that the path is going to be score-board, which if you saw earlier, I've already been to before. So we're just going to go there now. It's hopefully going to load. Now I go to my other instance of GShop and we save the whole thing. There we go. Not lying, it is actually the scoreboard. So here we are, here's the scoreboard, and it's gone grey. That's great. Just bear with it 1 second. It clearly knows I'm presenting and just decided it's going to be annoying.
You didn't pray to the demo gods, Jenny.
Do I need to do that like in the interim for the second challenge? So actually, like, come on, let's actually work. I do have. I actually got another instance of GShop running, so I'm going to see if that one beats it. There this one's actually boosting it. So I have 2 instances of GShop open. This one I'm running on Heroku. The other one I have running on a local Docker instance because I knew I could wipe it so that I could show you how to get to the scoreboard. So if the other one does load, we can go back to it. But this is the scoreboard. So we've got, this is all the challenges that are behind GShop. So you've got different stars, you've got little categories, and this is just all the injection ones. And we'll be going through, see the one that I've done is login admin, and that's what we'll be doing in a moment. So I'm going to hand over to Sarah now to give a little tour around GShop, and then we'll be back with me for the login admin challenge. Yeah.
Cool. I'll just share my screen now. Which screen to share?
Ooh, loads of options.
There are options. Let me just move this over. So yeah, we've just opened up the website. Now we have the scoreboard. We can start thinking about the challenges. Can you guys all see my screen all right? Just to check. Yeah, okay, cool. So we are faced with an application, and you may be thinking, well, this is a lot to look at. And for a long time, I used to think that as well. I didn't know where to start. And like Sophia said, it's just good to look at the functionality. You want to map out the whole application, see what it's doing, see what it could be running, and try and see what technologies are listed behind it. So we haven't logged in or anything. We just want to see what pages can we look at the moment. We know we've got products and we can see all these. We can search for products. I've just put in test. I wonder how it's bringing up products like this. You can look at products. You can see there's a review functionality. I mean, it's quite self-explanatory, but when I first open up any web app, I like to look at all of the pages. I want to see all the different links that it's going to, the about us, the photo wall. And then have I got to log in? Yes. I wonder what I'd have to do to log in. And like Natalie was saying earlier, that there could be a database of all the credentials being stored, and that's where the next challenge comes in that Jenny will talk to you a little bit more about. But honestly, you want to just have a look and see, first things first, what you can access as an unauthenticated user before you log in anyway, because you could see some low-hanging, you could like spot low-hanging fruit and exploit something quite quickly. And once you've done all of this, you can use tools such as Burp. So I'll really quickly click on Burp I opened earlier. This might be a little bit overwhelming if you've never seen it before, but first things first, there's this lovely little tab called Target. And if you open up a proxy instance and open up a browser, you can go to that website, and in the background, whilst you're clicking on all these different links, the application is actually being mapped out for you. And Burp Suite actually finds certain vulnerabilities occasionally. So you could, for example, log in, it might realize that there's clear text credentials being passed. So if I just quickly go back to that URL, I have so many things open, and of course it had to be shopping open, didn't there? That we were talking about earlier. So open it up in here. I just want to make sure that intercept can be off for this. It will still capture your traffic. You can still click around again, and I'll just do a couple of links because I know I don't have too much time to show you about this. And if we go back to Burp now, we can see that on the target, or this is probably listed some of the stuff I've done before, there are a bunch of different folders mapped out, very similar to when you see developer tools. It might capture JavaScript files. We can see if we can find that main.javascript file there. For example, it will just kind of store it all really nicely for you. And there's little quick ones it might capture. I don't think it's done it on here. It could just be because I'm using community edition of Burp Suite, but that will start, you know, just deconstructing the entire application for you. And then, for example, if we want to specifically think about where to start with SQL injection, then you might want to start thinking about, oh, I don't know what language it's being used behind it. What kind of, like, is it Oracle or MySQL? And there are some fun cheat sheets to help you as well with this. So Natalie mentioned in her slides some fun resources you can use to help you with that. And I've also opened up one of my own. If I can find the tab here. So if you really are stuck, there is a cheat sheet where you can start trying different things for like getting database version information, for example. That would be great when you're starting to map out the application. But overall, that's a good starting point to beginning any journey of a web app. And in general, SQL injection, you'll start thinking about, oh, where could this be pulling information from a database? So like the login, you might be thinking, oh, this could be using SQL, and it's always good to try and make an application error if you can. But overall, I'd say that's pretty much all I can say without going into too much detail, and it kind of leads quite nicely on to the actual challenge that Jenny is going to do for you. Sorry, two screens, I keep looking over here. But
it's really difficult with two screens, isn't it?
It is. It really
you always end up looking at the wrong screen, and then it just looks a bit funny, especially on the video for later.
Exactly. It's all about the method though, and just, you know, having your setup right.
Right. I think I can stop. Let me now share my screen back again. Make sure I know. Right. 1 second. I moved stuff. That was clearly a bad idea. I should have just left everything where it was. Share screen. Screen 1. Share. Is that on the right screen now? Can we see GShop? Having a right night moment. So we're going to go through the login admin challenge. So this is back on my original one. So this is all where the scoreboard wouldn't load. It now loaded. Thank goodness for that. So we're going to go look at the login admin challenge, which was a 2-star one. That was a bad move. I just clicked on something and it doesn't like me today. I'm going to give it a second, and if it hates me, I will go back to the other one, which did like me. There we go. So it's the login admin challenge. If it's not, yes, it is here. Cool. So it's this one here. So it just says login with the administrator's user account. It doesn't give that much detail right here. If you are wanting to go through more challenges, Sarah showed me that there are hints if you hover over this, and I missed this when I first started it. The hints are so useful. But we're going to go to the login page, and if you were clicking around, the login page is easy to find up here. It's being slow. It's being slow. Right. I'm just going to go. Where's my hero? I'm going to use the other one because this one likes me way more today. So I already have the challenges pre-solved on this one. So it won't come back saying that I've solved the challenge, but you'll have to just accept that we have solved the challenge when I say that we have. So I'm going to just reopen the dev tools for this. So as we've seen on Natalie's slides, and as Sarah just mentioned, the great first thing to do is just to try and get this page to error. And on Natalie's slides, we talked about just putting a single quote in, because that will mean that your single quotes, because they're going to be in pairs, they won't then be in pairs anymore because you're just putting in a single odd quote, and that will break the query. So we're just going to try that. We've got to put something in for the password, because in order to get this login button to be enabled. So we're just going to try that, and that's great because that means we have an error message there, and that is a bit disgusting and we don't like that. So what we can go is we can go now to the network tab, and we can see that we've got this in red, which is showing that there is an error there. So if I then click on that, we have loads of lovely information about what went on with this SQL query, and you can see here this is the actual query that it tried to call that went and errored. So if I copy and paste that and then put it into Notepad, just so we can see it a bit more clearly and in isolation instead of with everything else going on in the background. So this is our query. So we were selecting starts, that's all from that table, from the users table, where the email was equal to, and we can see here, that's where our single quote that we put in has been inserted. So because now we've got 3 quotes here, that one closes with that one, and then this one goes with this one, it then doesn't match up, and so there's now an odd number of quotes and it doesn't like it, and that's when it errored. We got, as we've discussed earlier, we've got the passwords that we put in, but it's been hashed, so we can't read that straight off there. So this is the query that we've got. So we now know that the single quote that I put in went in this slot here, and that's where we're going to try and put something else in order to make to log in as admin. So I'm just going to do it in Notepad, and then I will copy and paste it over into G-Shop in just a second. So what we're going to put in, as was actually on Natalie's slide and is a very common one to do, is do single quote or 1 equals 1 dash dash. And I'll just quickly talk through so we can see what's going on in this query here. So this is the actual query that we were doing. So it's exactly the same as the one that Natalie had on her slides, where we inserted, but that one has a username, and the only difference is we have an email and it's deleted out, we just ignore that. So we have select staff and users where email equals, and then we have closed this single quote, or 1 equals 1, and we know that 1 equals 1 is always going to be true, and so that all is always going to be true, so this statement is always true, and then the 2 dashes there are the comment, so the rest of that query we can just forget. So we were going to go and give that, put it into our thing, so we have single quotes or 1 equals 1 dash dash, and then we're going to try and log in. And now we have found that we've logged in, and as we could find out by clicking around, that this is actually the admin account. We didn't actually know it was the admin account when we logged in. We didn't specify who we were logging in as, but it's probably a good bet that the admin account is going to be the very first user in the table, the users table, and that star is going to get all the users, and then it's likely that the query behind the scenes of the code is going to get the first one on the top of the first row. And we can see here we've got admin at juice-sh.op, and that's quite useful to know that that's the format for all of the email addresses for the accounts there. So that is how you solve the login admin challenge. And I'm now going to pass over to Sophia, who's going to be doing a little bit more of an in details one. So work out how to stop sharing.
I have a really bad habit of forgetting to unmute myself and just talk to myself for like 5 minutes before realizing.
We would point it out.
I think, was it Sarah the other day? She was like, I thought everyone was ignoring me, but I was just on mute.
Probably.
Oh God. Cool. Hopefully this will work. Can you see G-Shop is the question.
Yeah, we can.
Cool.
I can.
Right. So now we sort of know a very sort of basic SQL injection. We're going to try something a little bit more tricky using the same theory before, but we're going to use the union attack. So Nat mentioned this earlier, it's kind of piggybacking off an initial SQL query to then do our own thing and grab more data, essentially. So this is a 3-star challenge, and it's database schema. And we basically want to try grab the database schema from the web app. So a database schema is essentially the structure of the backend database. So you want to find out what's going on sort of behind everything and the ins and outs of it. So we need to find an injection point. A very common one, and this was just kind of something you pick up, is search boxes. So if you put into the search box something like apple, you get your apple juice, your apple, I don't even know what that is actually. And if we proxy this through burp, and I just need to grab my burp. Here it is. So this is the interceptor that I was talking about earlier. What burp will do is when I click searching for apple, it should, bear with me 1 second. I didn't pray to the demo gods, clearly. Nice. Okay. Luckily, I have a backup for this. I'm not sure why that isn't proxying.
It's like we knew we had backups in place.
Yeah.
It was just going to break, so we'd have to use the backups.
Okay, it is proxying again. Maybe it's having a moment. It's fine, I've got a backup. Okay, so here is the request that we should have captured if burp decided to work today. And you can see here that the query is apple. So if we take that out and send it, you can see that it successfully retrieved the apple juice product and the apple pommes. I'm still not a clue what that is. It's got all the apple stuff. So now if we add a single quote, which is what Jenny was mentioning about kind of trying to trigger errors and breaking the query so the database freaks out and spits an error. So if we send that, it has indeed freaked out and sent us an error, which is useful for us. So you can see here that it's an SQLite error, which gives us an idea of what kind of software it's running. So SQLite, and it's actually quite usefully given us the actual query string it's running. So you can see here it selects all from products where name like apple. So this is where our input is going, or description like apple, and then a bunch of SQL stuff. So what we want to try do is escape this query so we can inject our own query to get that database schema for the task. So you can see in here, it's a bit of a tricky one. It's a bit complex because you have to get out of this quote, and then you have to get out of this bracket, and then you have to get out of this bracket to close the query. So if we do that and put the 2 brackets there, including the 1 quote we use to trigger the error, we still get an error, but you can see that it successfully injected it into that sort of input field. And if you read it sort of throughout, it closes everything within. So now we can start tampering with putting in our own query to get the data that we want. So we're going to use a union attack, as I mentioned, and this is, you can quite clearly see here, it's piggybacking off that initial query that we're asking the database to do. So if we do union select, and I'm going to bring up a cheat sheet that actually Sarah's already shown you, but it's quite handy. This is just a Portsmouth cheat sheet, and you can see here the best way to try retrieve contents from a database is using the select all from, choose whatever database you want. So that's why we are doing the union select. So union select basically is kind of the translation of that select, but in a union query, if that makes sense. So that's all good and dandy, but now we need to figure out what kind of default databases are in the SQLite framework that we can query, because there's no point just guessing and putting in random tables if they don't actually exist. you'll be wasting a lot of time. So if you go to the documentation of SQLite, which is always a very handy thing, reading documentation. So once you figure out a particular software package or particular kind of framework web app users, always just have a look at the documentation and see if you can pick anything out from there. And you can see that the schema table can always be referenced using the name SQLite schema, so that's a possibility. But there are also some alternative names as well. And just for the purpose of this session, I'm going to tell you which one it is, but in sort of a real life scenario, you would kind of collectively go through each one until you found it. So it is actually SQLite master. So if we add that to our query, so if we select, let's just go for one from SQLite master, and then we have to remember to URL encode this, otherwise it won't recognize it and it'll freak out. And then remember our little comment at the end, just in case it decides to put in any further random SQL stuff. And then we should send it, and we're still getting an error. But this is okay, because this is part of the process. This is how we get root. Fact. No, so this is kind of showing us, okay, we're sort of there, but with a union query to work, and Portsuga has a really nice article on union queries, which I'll quickly show you here. So for a union query to work, you have to be able to feed the query the correct amount of columns for it to work. So if, for example, I'm feeding it one column, but there might be more columns, bit of foreshadowing, and it will always error. It will keep telling me there's an error until I feed it the correct number of columns. So you can see down here, you can union select null, union select null, null. And it's just kind of this process of feeding the query columns after column after column until it's happy and it doesn't error anymore. So if we go back to burp and then unencode this so I don't get confused. So if we do union select 1, 1, and then try that, it still errors. And if you go through this process of adding sort of 1, 1, and then 1, and then 1, and then 1, just for time's sake, and because we're quite constrained for time, I'm going to tell you what how many columns, so we're not just sat here putting in ones and boring you to death. So little bit of a, I guess, a spoiler. There are actually 9 columns. So if you send it, you finally get a success, it's not complaining anymore. But if you take out, let's just take out that, it will error. So once you feed the query the correct amount of columns, it's all happy, and then you definitely know how to structure your kind of payload, I guess. So we now know that there are 9 different columns in the SQLite master table. And what we want to do is we want to try get some information out of that. But how do we do that? We go back to the documentation, because no one ever reads the documentation. And it's actually quite useful. It's very boring, and they probably deliberately make it boring, but it's actually got some very good stuff in it. So you can see here that in the schema table, there's different kind of, fields and columns. And again, in a real life kind of situation, I personally would try every single one of these and see which one gives me the data that I'm after. But in this particular instance, we're going to use the SQL, and this hopefully should give us the things that we need. So if we go back to burp, and then we're going to put SQL in the first field. So it's going to be union select SQL 2, 3, 4, 5, 6, 7, 8, 9. from SQLite master, and then we're going to comment out the rest of the query in case it decides to chuck in some stuff. You can see we've retrieved the schema. Ta-da! So that's kind of what we're after. You can see that it's got all the different tables. It's kind of got the structure of the tables as well. And you can actually see the columns as well. So that's why we put in 9 different things, because it's got 9 different fields, I guess, that you can look at or feed information into. So I appreciate this might be very, very scary if you haven't done burp or SQL injections before, but hopefully you kind of have a slight understanding of a little bit more of a complex injection payload. So I'll just do a quick recap, because I can appreciate that it's been a lot of information in a very small amount of time. So what we basically have done, we broke out of the query using the 1 apostrophe and the 2 brackets. So that closes the initial query to the database so we can inject our own query. And then we're using a union select injection, because union allows us to do multiple selects in one query. And that allows us to get the database information that we want. And then we had to find out the amount of columns in the database that we wanted. So we trialed and errored. Well, we didn't. I told you how many columns there were. But in a perfect world, you will trial and error, and you do the 1, the 2, 3, 4, 5 until the database doesn't complain anymore. And then from that, we go back to the documentation. We see what we can actually retrieve. We found SQL and retrieving it from the default schema table, SQLite master, and that's how we got this. So hopefully you guys have a sort of understanding. If not, please feel free to ask questions. Have a look at the Portswigger article. It's a really, really good article. And there's also loads of different online kind of academy stuff you can do as well. But yeah, I guess that's my bit done. And I think we're open for questions now, I think.
Yeah. Natalie, do you want to stop recording? Or, oh, I have these permissions.